Hello and welcome to the Math Studio. In this video, we're going to test for continuity with piecewise functions, and we're going to use an example here. So I've defined a function x here as sort of a combination of three functions. So f of x is x minus 2 for values of x less than or equal to 3. F of x is negative 2x plus 7 for x greater than 3 but less than or equal to 5. And f of x is x squared for values of x greater than 5. So, of course, we can graph that. So, for example, if you wanted to use Desmos or a graphing calculator, of course, you can see sort of fairly quickly which pieces sort of join together and which do not. However, we're going to test for continuity algebraically. So, just a quick recall, continuous functions or continuity is any function that can be drawn without lifting sort of your pen off the page. So, if I was to sort of draw that, that's a continuous function. It's not smooth, clearly. I mean, there's some sharp sort of corners there, but clearly this is a continuous function because it can be drawn without lifting the pen from the whiteboard. Okay, but we're going to test for this algebraically. So what we're going to do is let's analyze the first piece. Now, the first piece is defined for values of x less than or equal to 3. The second piece is defined for values of x greater than 3. So x equals 3 is a potential connection point. Okay, so the first connection point may be at x equals 3. And I say may because they may not connect. It might be a discontinuity at that point. The two functions might be off from each other and you can sort of see a clear gap. So what we're going to do is we're going to test the first piece and actually we're going to evaluate the first piece at x equals 3. So y equals x minus 2 at x equals 3, okay, and y equals 3 minus 2, okay, so y is equal to 1. Now we're going to test the second piece. So what we're going to test y equals negative 2x plus 7 at x equals 3. And we can see if we substitute x equals 3 into this piece, negative 2 times 3 is negative 6, negative 6 plus 7, y equals 1. So therefore, at 3, 1 is the point where these two pieces in fact join or connect. So these two pieces are in fact continuous. Okay, so y equals negative 2x plus 7 are continuous at, and I might just state the coordinate at 3, 1. Now we need to test the next two pieces. Okay, so we can see that the second piece and the third piece, so this is sort of a linear function and a parabola, a potential connection point, or they may be connected at x equal 5. So you can see here that you can sort of see where the connection points are. So there's sort of, I might just sort of highlight it there. So there's one connection point, and this is potentially the other connection point there. So this is the second one that we're testing. So, okay. So the second connection point may be at x equals 5. So let's test that. Okay, so y equals, and it was negative 2x plus 7. Yep. Okay. Okay, and if you substitute 5 into that equation there, so we got negative 10 plus 7, y equals negative 3. Now we have y equals x squared. Okay. At x equals 5, substituting 5 into this equation, we have y equals 25, and they're clearly different. Okay, so negative 3 obviously does not equal 25, so therefore y equals negative 2x plus 7 and y equals x squared are in fact discontinuous. At x equals 5. So there'd be obviously a clear gap. So negative 2x plus 7 would be probably a function that does that. Okay, and the parabola probably obviously is way up here, will probably do something like that. And so this would be your discontinuity. Okay, thanks for watching.